How would you like the ability to start up a new container on a new node, but not have to wait for the image pull and decompression? With Project Teleport, your containers are now ready in mere seconds. Steve Lasker is here to show us how it works today on Azure Friday. Oh, Steve, nice of you to join.
I'm here to get started with a little teleportation.
Well, that sounds great. It sounds like today we are going to talk about Project Teleport.
Yeah, so what we love about containers is their ability to bring their whole environment with them. Right? I get the whole environment, I get the OS, I get my configuration that I can inject, and that's awesome. The price of admission is that first time you pull, you have to wait for all the layers to come down and then wait for decompression. So that can take quite a while. In fact, it becomes the inhibitor to a number of the scenarios, like in serverless kind of scenarios. So we've always felt that having images as close to the deployment as possible is really important. So 2 years ago, we released the geo-replication feature.
Yep.
So if I'm in 2 different regions, I'm always pulling locally, and we do the replication behind. With Project Teleport, what we wanted to do was make it inside a region also be just as fast.
Okay.
If you think about the way the Docker flow works, and we've got a little animation here for this, when I have a Docker pull or a Docker run, right, it asks for something at the client. It goes to a registry and it says, hey, I want this thing. There's a manifest that comes back that has a set of layer IDs, and the client looks at those at the cache and says, do I have anything? It's like, I have some, but maybe not all. So it goes, hey, registry, can I have some blobs that represent this? For the internet, it's great because you want them compressed.
Right.
Because the internet's kind of slow.
Yep. You're sharing that with a lot of other things.
Yes, exactly. Like all your Netflix videos and everything. And I have to wait for all these layers to come down and decompress. So it's great for the internet, but inside a data center, that's not the most optimal. So if we look, and I've got nothing up my sleeves here, so we'll just run this again. So now you've got some context to it, right? We're pulling those layers down, it's decompressing them.
You're waiting for the extraction, yep.
And you're like,
waiting and waiting, yep.
And eventually you will get the image. Now the second time, it runs fast because it's there.
Yep.
In serverless scenarios, I don't really have a second time because everything's new. So that's the piece that we want to improve. And it's almost there.
Right. And it's just going to get worse and worse depending on how many layers you have and the size of each. Right.
Right. Yeah. The bigger the image, the more it's going to take. So here it took 36 seconds for this image to get started. And for the sake of consistency, I'm just saying hello in it. With Teleport, what we do is the startup is the same. Right. I want to run that job. It asks for the layers. It looks locally. But now what we do is we say, all right, we're in Azure. We know we got this optimal network. The compute disk speed and memory is the bottleneck, not the network. So what if we ask for layer mounts and then just do SMB mounts so that we're only going to pull the content across that we actually need? So turns out that can actually make things a lot faster. So just grab my other snippet here.
So you're skipping all of the decompression, and you're just bringing that layer straight over.
Correct. So we've enabled this in preview with ACR tasks. It's just a very optimized container build and runtime environment. So that's what you're seeing here is we basically run a ACR task, and you'll see it says Orca run. And if we look, while we had the startup of the serverless environment for ACR tasks, we see the actual image time was 4 seconds.
That's quite a bit. I mean, I didn't look at the final number before, but it was much more than 4 seconds.
It was like 36 or something. And this is a relatively small image. So we can make some pretty significant changes, deltas here. I mean, especially, like that was a dedicated VM.
Yeah.
Right? I'm like working directly with it in comparison. If we think of things like here's some ACI comparisons, the numbers get pretty dramatic. And even with Spark notebooks, with machine learning, these jobs can get pretty big.
Yes, because that image, and as you can see, that 34 layers, and the dedicated VM is significantly higher than what we're seeing in
Yeah.
Teleport.
I mean, what you're actually seeing is the numbers are really related to the layer count And that's actually one of the optimizations we're working on
Right.
as well. So just a little bit more, like how does some of the magic work, right? In the top one, we have a Docker client on both sides. A Docker push, they're compressed blobs, and the Docker client only knows to ask for compressed blobs. In our bottom one, we have a Docker client, but then we have a teleport enabled, we call it Orca, just a little Project Orca, it's just the way we've plumbed this together for now. And what it does, it says, hey, I'm an Orca client, I'm in the same region, don't waste my time with this internet protocol stuff, just let me get to the layers.
Okay.
And you can kind of see the different permutations, like we'll eventually have tasks that can push expanded layers, so pretty cool.
Yes.
So that's really it. Our goal is we currently having preview in Linux with ACR tasks because it's a constrained environment, so we can do things really quick and really efficient and get feedback. And then based on that feedback, we plan to roll it out to every service in Azure that runs containers can run Teleport,
Right.
both Linux and Windows.
Yep, that was going to be my next question. So you said today we have Linux, and we will be supporting Windows, so that'll be a great addition to this. And I see that you have a number of services that you'd like to also light this up with.
Yeah,
And
pretty much anything. Anything that runs containers in Azure, we can do this, right? Because it's the whole idea is we're leveraging that inside the Azure network. We're leveraging premium files from Azure Storage.
So machine learning and your serverless, all of these scenarios are just going to be that much better in Azure.
Yeah, you don't have to wait for that startup time. So we'll just unlock a bunch of scenarios.
That's great.
So we're definitely looking for people to give us a try. So please sign up, let us know what you're doing. And we'd love to get your feedback because the more feedback we get, the faster we can roll it out to all these other services in Azure.
Fantastic. Is there anything more?
I think that's it. That's it for now.
Well, thank you
All right.
so much for joining today.
Yeah,
it was
thank
great
you
to
for
see
getting me
Project
in.
Teleport. I'm excited to see this become available in more and more services.
Yeah.
So, all right.
So are we.
We've been learning all about Project Teleport today on Azure Friday.